Gravity. It's a fundamental force in our universe. You can't see it, but you can certainly feel it. Gravity is what keeps your feet firmly planted on the ground. It's what makes objects fall when you drop them. But gravity is much more than that. It's the invisible glue that holds our solar system, and indeed the entire universe, together. Gravity is a force of attraction between any two objects that have mass. The more massive an object, the stronger its gravitational pull. This means that a planet like Jupiter, with its enormous mass, has a much stronger gravitational pull than a planet like Mercury, which is much smaller. This force of attraction doesn't stop at planets. It affects everything in space, from the smallest asteroid to the largest star. Gravity is the reason why planets orbit stars, why moons orbit planets, and why galaxies cluster together. Understanding gravity is key to understanding how our universe works. It's a fundamental force that shapes the cosmos and influences everything around us. Mercury, the smallest planet in our solar system, is a rocky world, scorched by the sun. Because of its size, Mercury has a weaker gravitational pull compared to Earth. Imagine you weigh 100 pounds on Earth. If you were to stand on the surface of Mercury, you would weigh a mere 38 pounds. This is because the gravitational force on Mercury is only about 38% of what it is on Earth. This weaker gravity means that Mercury has a very thin atmosphere, barely there at all. It's not strong enough to hold on to gases like Earth can. Venus, often called Earth's twin due to their similar size, is a planet of extremes. Its thick atmosphere traps heat, making it the hottest planet in our solar system. And its gravity? Well, it's pretty intense too. The gravity on Venus is about 90% of Earth's gravity. So if you could withstand the searing heat and crushing pressure on Venus's surface, you'd feel slightly lighter than you do on Earth. That 100-pound person would weigh about 90 pounds on Venus. This strong gravitational pull means that Venus has held on to a very thick atmosphere, much thicker than our own. This atmosphere is what contributes to the runaway greenhouse effect that makes Venus so incredibly hot. We experience Earth's gravity every single day. It's what keeps us grounded, literally. It's what makes the rain fall from the sky and the oceans ebb and flow. We're so used to it we hardly even notice it's there. Earth's gravity is what determines our weight. It's the force pulling us towards the center of the planet. The more massive an object, the stronger its gravitational pull, and Earth has just the right amount of mass to create a comfortable gravitational force for us. This force is what allows our planet to hold on to its atmosphere, providing us with the air we breathe. It's also crucial for the existence of liquid water, a key ingredient for life as we know it. Section 5. A lighter step, gravity on Mars. Mars, the red planet, has captivated our imaginations for centuries. But if you were to set foot on Mars, you'd notice a distinct difference in gravity. The gravity on Mars is only about 38% of Earth's gravity. This means that you would feel much lighter on Mars. If you weigh 100 pounds on Earth, you would weigh only 38 pounds on Mars. Imagine being able to jump 3 times higher or lift 3 times heavier objects. This weaker gravity is one of the reasons why Mars has a very thin atmosphere. It's simply not strong enough to hold on to a thick blanket of gases like Earth can. Section 6. The giants grasp gravity on Jupiter. Jupiter, the largest planet in our solar system, is a gas giant with an immense gravitational pull. Imagine a giant vacuum cleaner, sucking in everything around it. That's kind of what Jupiter's gravity is like. The gravity on Jupiter is a whopping 2.5 times stronger than Earth's gravity. So if you could stand on Jupiter's cloud tops, which you can't because it's made of gas, you would weigh 2.5 times your weight on Earth. This incredible gravity is why Jupiter has so many moons. It's like a cosmic shepherd, gathering a flock of celestial objects around it. Section 7. A ringside seat gravity on Saturn. Saturn, the ringed jewel of our solar system, is another gas giant with a powerful gravitational pull. Like Jupiter, it's a massive presence in our solar system. Saturn's gravity is only slightly stronger than Earth's, about 1.06 times stronger to be precise. While that might not seem like a huge difference, it's enough to make a big impact. The most obvious example of this is Saturn's rings. These rings, made up of countless particles of ice and rock, are held in place by Saturn's gravity. Imagine a cosmic ballet, with Saturn's gravity as the choreographer, guiding the movements of these icy dancers. Section 8. The tilted world gravity on Uranus. Uranus, the ice giant, is a strange world that's tilted on its side. It's like a spinning top that's been knocked over but keeps on spinning. And its gravity? Well, it's a bit of a puzzle too. Uranus's gravity is actually slightly weaker than Earth's, about 89% as strong. So, you'd feel a bit lighter on Uranus. But, here's the thing. Uranus is tilted on its side and it rolls like a ball as it orbits the sun. This unusual tilt affects its gravitational pull, making it uneven across the planet. Section 9. Distant blue giant. Gravity on Neptune. Neptune, the farthest planet from the sun, is a cold and mysterious world. It's a giant ball of gas and ice, and its gravity is nothing to sneeze at. Neptune's gravity is about 1.14 times stronger than Earth's. That's just a bit stronger than our own planet. This might not sound like much, but it's enough to keep Neptune's atmosphere from escaping into space. This strong gravitational pull is also responsible for Neptune's impressive storms. These storms, some of the largest in our solar system, are whipped up by Neptune's powerful winds, which are driven by its internal heat and influenced by its gravity.